This is the brief on mathematical physics and material fundamentals. We're looking at a few key visual proofs that really demonstrate the mechanics behind things like conservation laws, the math that governs flow, and, well, the core differences in how materials behave. First up, let's talk about the mathematical analysis of flow, or what we call vector flux. The flow crossing any given surface is determined only by the component of the current that's perpendicular to that surface, hitting it straight on. So if the current is just running parallel to the surface, well, that perpendicular component completely vanishes, and the flux just drops to zero. Second, the origin of conservation laws. The law of conservation of momentum, it's a direct consequence of Newton's third law, the whole action-reaction principle. In any closed system collision, the internal forces are always equal and opposite. They perfectly cancel each other out. This means the total momentum of the system has to remain perfectly constant. And finally, let's get into a fundamental distinction in material properties. Thermodynamic properties are split into two types. You have intensive properties, like density, which stay absolutely constant no matter the size of the system. But then you have extensive properties, like mass, which are additive and scale right along with the system's volume. From perpendicular vector components to balanced internal forces, these principles are the essential foundations for modeling dynamic physical systems.